Jai Jinendra, Namaste and welcome to my channel. Today we are going to solve the 57th question of the problem solving series and we are going to start the new topic recursion. As you all know, recursion is a very important topic in DSA and programming language. This recursion concept will be used in dynamic programming questions and solving backtracking questions and binary trees. Even in other data structures also we use recursion. So it's very important, we need to solve some number of questions that are important to clear the concept of recursion, and also these questions are directly asked in the interviews. So we'll discuss the subset sum problem. This is a very general problem for recursion, and we'll understand what is the logic that is used very specifically, because this logic will be used in a lot of times while solving questions in dynamic programming. Because dynamic programming, where we use recursion and then we optimize recursion using our extra space. So you need to understand the concept of recursion very clearly, and there are some couple of examples, not couple, like few examples where you can need to understand the pattern, and this pattern will be used in the coming problems when we will discuss binary trees and specifically dynamic programming. Okay, so before understanding the question subset sum, looking at the examples, we need to understand what is recursion, like how do we define recursion. So when we write functions in our code, so when a function calls itself in its function, then it is a recursion, right? For example, if there is a function f and it does something here, there's some code is written and then again it calls f and some code written. So when a function is calling itself, then it's recursion, right? So there will be a recursion stack tree will be formed, that okay, for this input there is some input, this is called, and then again this is called, and you will see that there will be some condition by which this function will be terminated, and then this tree, after termination of this, the next code will be executed. When this gets finished, then this will be executed. Or if there is some more number of functions called, like 2-3 functions, then in that way a tree stack would be formed and final output would be gone after all these functions that were called after this, from this. When that gets solved, then the final output will come. Okay, let's understand with the help of an example. So we'll just code a basic questions. I think I have solved this question while I was teaching arrays. So power of a, b, right? So we need to calculate a to the power b. So it's very simple, right? We use loop and we will have a condition. We will run a into a till b. Okay. So if say a is 3 and b is 4, so 3 into 3 into 3 into 3, right? So this is 81, right? So we can solve this question using recursion as well. Now, how do we solve a question using recursion, right? So you need to remember 3 basic steps to solve a question using recursion. What are the 3 basic steps to solve a recursion question? You need to find the base case of the problem. What is the base case? So we will discuss. We will see how do we solve this question. Say int f a comma b is given to us, and we will write a recursive function to solve this problem. Okay. So the second, after finding the base case, we will find what is the base case for this example. Okay. So we need to find the relation between the problem, the bigger problem, and the sub problem. Find the relation between the problem and sub problem. Once we do this, once we understand what is the relation between the problem and the sub problem, just generalize the relation. And after generalizing, just believe in the leap of faith of recursion and the question will be solved. Now how do we do this? How we will solve this? Okay. So base case is you can say it could be a termination case or it could be the starting case of a function, right? So say if what if this b, okay, we are multiplying a till the time b number of times. Okay, we are multiplying a b number of times. But what if b is 0? So we will multiply a with 0 number of times, right? So we can't, if b is 0, we should terminate it, right? So what is the base case here? If b equal to 0, then you return 1. Okay, because anything to the power 0 is 1. You remember, right? Basic maths. So you need to return 1 when b is 0. Okay, so if the question is given 5, 0, if the input is f 5, 0, like if 3, 0, instead of 3, 4, 3, 0 is there. So in the base case itself, when they see that the b is 0, we will return 1 and our problem would be solved. But what if b is not 1? Then what is the relation, right? So when we solve it using loop, like, right, for I equal to 0 to b, return a into anything we have, sum is equal to sum into product is equal to product into a, right? We keep on multiplying a till b number of times. Okay, now same thing. So like if we have one basket and it has a capacity of holding 5 oranges. So you enter one orange, then you enter second orange, then you enter third orange, then you enter fourth orange, then you enter 5 orange, then the orange gets empty, full. But when you remove it, so you remove it and then there are 4 oranges, right? One has been removed and again you removed it. So similarly, if we are multiplying a, we need to call the function again, right? That is the recursion, right? Return f has to be called again. But if we call f, then already we have computed 1, and once again when we call f, then don't you think we need to reduce the value of b again? Because one time if you have done it, then you multiply return a into f a comma b minus 1, right? So the relation between the problem and the solved problem, we understood what is the relation, and then we generalize this relation like this, right? That we will multiply this a into whatever the value of this is. So f a b minus 1 will be called again, say for the example of 3, 4, right? So for 3, 4, how would be the stack space? 3, 4. So first 3 into f 3, 3. Then 3 into what this 3 into 3 will return? This will again return 3, 2. And then this will return again 3, 1. And that way there will be 3 into 3 into 3. So 81. So this will be finally would be returning 81. So from the bottom we will start. Once this 3 to the power 0 would be computed, it would return 3. Then 3 to the power 2's value would come and 3 into 3 would be multiplied. So it would become 9. And then this 9, 3 to the power 3, 3 into 3 to the power 2 into 3. So this would become 27. And then 3 to the power 4 was called as 3 to the power 3 into 3. And this 3 to the power 3 is computed as 27. So 27 into 3, 81. So in this way, we have solved the problem of a recursion. So there will be a lot of problems of recursions. You need to understand, you need to follow this recursion 3 steps. Find the base case, think about the base case, then think about the relation between the problem and the sub-problem, divide the problem into sub-problems, and then try to generalize the relation. Okay, the time complexity of recursions is 2 to the power n. Because of the stack space, we are going again and again. So mostly if we have we have the option of like choosing between two things, so 2 to the power n or exponential, right? So now, since we have discussed this, now we'll discuss the example and understand the question. And I hope if you have forgotten what is recursion, so that's why it took some time to explain what is recursion. I hope it is helpful for those who don't have forgotten or who are not, for whom the recursion topic is not clear, because if this is not clear, you will not understand the further questions which are very important. So now let's understand the question. Subset sum. So we are given an array and we need to find all the possible sums of the subsets. So how many number of subsets a set has, right? In maths, you know. So here there are 2 elements. So you know that the number of subsets possibles are 2 to the power 2, 4. Here there are 3 elements. So the number of subset possibles are 2 to the power 3, 8, right? So here, for example, this one, what are the subsets? You take nothing, you take 2, you take 3, you take both 2 and 3, right? Now these 4 subsets will have different sum. So you need to print the sum of all the subsets, right? So for this one, the sum would be, what is the sum of this one? 0. What is the sum of this one? 2. What is the sum of this one? 3. What is the sum of this one? 5. So you need to return 0, 2, 3, 5. So here in this case, okay, so what would be like, there would be 8 number of subsets and you need to find the sum for all of them, right? So starting it would be 0, right? So one way it could be, first let me write the answers and then we will discuss how we will solve this question using recursion, using the 3 steps that we discussed. Find the base case, I'll write here again. Find base case, relation between subproblem and problem, and then third one, generalize, right? Okay, so before the difficulty level for this question is medium, and this question has been asked in Adobe, Microsoft, Flipkart, Cisco and many other companies. Okay, so yeah, let's discuss. So now one way to, like, there could be multiple big array, right? How many times, how long we will take, we'll need to find all the subsets and then we need to calculate the sum. Okay, so one way is to find the subsets, generate the subsets, okay, using recursion, or using recursion only we can generate the subsets. So that would be another question, how to find all the subsets. But here we need to find the sum of the subsets. Okay, so one thing is, for finding the sum of the subset, even in the probability, what we do is we have 2 options, either to take anything and not take anything. So this take and not take logic we will use to solve this problem. Okay, so for this example also, say you took 5 in your sum, okay, in your subset. So you have option of taking 5 and then you come to 2 and you think, okay, I will not take 2, and then you come to 1, you think I will not take 1. So you only have 5, but then you again think of taking 2. So you took 5 and 2 both. So 7. So like this we can form all the subsets. Okay, now you have 5 and 2 both, and then you think of taking 1 also. 8. Okay, so there was one more thing. You took 5 and then you did not take 2 and you took 1. So 6. Okay, now you don't take 5, you just take 2. You take both 2 and 1, 3. Okay, and then you don't take 2, you just take 1. Okay, so how many has formed? 4, 5, 6, 7, 8. So we have formed all the 8 elements, right? So now what did I do here to solve this problem? Let's discuss this. Okay, so 5 to 1. Okay, we have 5, 2, 1. So one option is there, when we are in 5 we will not take anything. Okay, so you have option of taking and not taking. Okay, so when you decide to take 5, then the sum of 5 is added to the sum. Okay, and then you took 5 and then you have 2 and you have 1. Okay, so say you have taken 5 and then again your function comes and you decide, okay, you move to the 2 and then you decide take and not take. Okay, you take 2, then 5 and 2 both are there now. Okay, and the second thing is you don't take 2, So you have 5 comma 2 comma 1. Now here when you come, you have taken 5 comma 2 and then you decide to take 1 as well. So 5 comma 2 comma 1, and then here you decide, okay, so once you have taken 2, you move here, right? So you have taken 1 and here you have said, okay, I will not take 1. So once this element has been finished, can you go again? So you started from here and you finished here and you can't go again any other place. So what is the base case? So when we finish the index, then since if we start from 0 and then we finish the size of the index, then we stop and whatever is the elements that is there, we can find its sum. In this case we have taken all the 3, so sum was 8. In this case we have taken 5 and 2, the sum was 7. Now this part is there. Now we will solve this. So here we were taking 5 and not taking 2, and then here we decide to take 1. So 5 and 6 is there, and then here we decide not to take 1. So only 5 is there. So here 8, here 7, and this one will be 6, and this one will be 5. So we have got 8, 7, 6, 5. Now in not take, you did not take 5. So you have 2 comma 1. Now you have a decision to make, take and not take. So from 5 you have come to 2, and now you decide to take 2. So 5, 2, you add it to some variable, okay, and then the sum becomes 2, and here you don't take 2. So here also you move to 1, don't take 2, and here you took 2, and now here when you go again, so you have taken 2 and you have taken 1 also, and here when you go again you have taken 1 and here you have not taken 1. So this will be empty 0, this will be 1, and this would be 2, 1, 3, and this would be only 2. So in this way you have formed the recursion stack, and finally you get the answer of your subset here. So in this way you can build a recursion tree to think about the base case, the relation between the problem and the sub-problem, and then generalize. Now we have done this. Now we will follow these 3 steps, okay? Index getting n, okay? And what is the relation? We either take and not take. And then how can we generalize? We add it to the sum. We should have a something that has to be added, okay? So we need to store, right? We need to return vector. So every time whatever the sum we get, we need to add it. When we will add it, when we will get the base case, right? So once I code it, you'll understand. Okay. So now we have this subset sum function, and what do? We find out the size of the array, okay? Firstly, array dot size. Okay. Now we need to call a function that calls itself. Okay, we can't have the size every time calculated. Okay, so we'll write a function. We'll call a function. So what do we need? We need an answer. Okay. So we will pass answer. Okay. And then we need a sum every time. Okay. So we'll pass that also. Okay. So we will call a function, say subset helper. Okay. And that would return a vector of answer. And this answer, and then this is will return this answer. Okay, return answer. Okay, and our function will be added, and here what we will do? Okay, so this subset helper would return the answer vector int. This is our recursive function, subset helper. Okay, now what should we have? We are moving from 0 index, right? So we will pass 0. So it would be our index. Okay. Then what do we need? We need a sum. Okay. So some variable that keeps on getting added, right? So the sum will be initially 0. Then what we need this array vector of int and percent array. Okay, so we'll pass the array. Then what do we need? We need the size. Size is n. Okay, because we need to compare when the index becomes n, it would be our base case. And then what we need? We need this answer. So we will pass this. We can pass this in any order. Okay, no problem. Obviously, you know that vector int and percent answer. Okay, so this way we have declared our function. Now, what did we learn? We will write the base case. Okay, so what would be the base case? If index equal to n. Okay, that means we have reached it. So what we'll do? We will add this. We can make it as a void call as also. Okay, we don't need this because we are passing answer. So we will modify the answer automatically. Okay, so answer dot pushback, whatever the sum value is, we will push. Okay. Okay. And this would be our base case. Now, what did we learn? Either we pick the element, relation between the problem and the subproblem. What is the relation between the problem and the subproblem? When we discussed, we either pick and we don't pick. Initially from the index, we will starting from the zeroth index. So we can pick the zeroth index and we can't pick the index. So where can we pick it? So we have this index, right? So we will pick the element in the beginning. So how we will pick the element? I'll show you. So we will call this function subset helper again. Okay. We have to call it. It's a recursive call, recursion, right? We are learning recursion. So in this one, we need to move forward, right? So index plus 1 we will do. Then what would be the sum? In the sum, we decided picking the zeroth element. So the sum would be sum plus array of index. What is the index right now? 0. So we have taken the first element, zeroth element. Then we pass the array, we pass the answer, and we pass n. We have picked here. Okay. Now this function will pick, and then again this thing will happen, and then second time what we'll do, like when we rooted, right? We had two options, either pick and not pick. So pick is done. Then we will not pick the zeroth element. So subset helper we will call again, and here we will move forward, but the sum would be same, that is 0 in this case, right? Whatever the parent function, the parent function had, same we will pass. We will not increase the sum. We will pass array, we will pass answer, and we will pass n, right? So in these three lines of code, we have solved this problem, right? Just live in the leap of faith of recursion. Once you do these 3 steps, the problem will be solved automatically. Just try to dry run this code using the stack space that I told you, and you will see that this would be returned for this example or any example, right? So in this way, once this is finished, all the functions are terminated, all the functions reaches this n. So automatically this answer.pushback has all the different sums, and this function would be terminated, and we will return the vector of answer, right? So I hope the explanation is clear. I have explained in detail about like lot of things about recursion. I have revised the concept of recursion. I have discussed this subsets of problem, this 57th problem, and have coded the whole solution only. And now try to solve the question by yourself. The link to the question has been given in the description. And then come to my code walkthrough section. What would be the time complexity? 2 to the power n. What would be the space complexity? So we have not taken extra space, but though there is a stack space. So stack space the time complexity and the space complexity both would be 2 to the power n. Okay. And so the link to the question is in the description. Try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 57th question and the first question of recursion topic, subset sum, in the Geeks for Geeks platform. And yeah, we can see the code here. We have this array and the number of elements of the array, and we declare this answer and we pass subsets this arguments to the subset sum helper, which is our recursive function. And we do the same thing here, whatever we have discussed. And then yeah, so we need to return it, right? I think I have not written this return, because once this condition is done, we will not be executing again, right? So we need to return once the base condition we have reached. We need to exit from the function, right? So we will not execute the other things once we have reached this base condition. Okay, so this return is important. And then we pick the element here, we add to the sum, and then we don't pick it, right? The order of arguments is different from what I have discussed, but you know, it's same. So once we have got, we need to, the output can be printed in any order, but here we have just sorted it so that it looks good, right? 0 2 3 5. Even if we don't, so our answer would be right. Okay, so let's run it. Okay, compilation completed. The output is same as the expected output, so we submit this. So it has passed, you can see. So see you all soon in the next video, where I'll be explaining the second question of recursion and the 58th question of my problem solving series. Jai Jinendra.